Okay, gang, this is yet another Screencastify where I get to hear how weird my voice sounds. All right, what I've done is I've solved practice problem 1 here from I think it's the second set of practice problems from today's work. I just want to go through it with you. I can't figure out how to type it in real time, so you're going to have to bear with me. All right, so let me get this guy. All right. So if we read through, an applied force of 450 newtons forward is needed to drag a 1,000 kilogram hickory crate at constant speed across a snowy surface. Calculate the coefficient of friction for the crate on the floor. Apparently there's snow on the floor, I guess. All right, let's have a look at this. First of all, constant speed. This implies that the acceleration is 0, and therefore the applied force forward is equal and opposite to the frictional force going backwards. That is one of the subtle things that you're going to see a lot of, okay? So I don't know if I can highlight this stuff at all. Let me see what I can do here. But yeah, so constant speed, that's an important point. So acceleration, oh, here we go again with my terrible mouse skills. Acceleration is 0, okay? And that means F net, oh, getting a little better, also equals 0. So F net, of course, is a vector. All right, now I've messed that up nicely. So acceleration 0, F net is 0. That means this 450 newtons over here will be the same as the backwards pulling force over here, 450 newtons. So I've broken it down. There's our given. Well, the free body diagrams you're given. Always, 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 always do a free body diagram. If you don't have one of these, then you don't get one of these, an F net statement. So if we look at our Newton's second law, basically says F net equals ma. F net equals ma solves every problem. Not most problems, but every problem in dynamics. So if we say that F net equals ma, I should have written that down initially, which equals 0, because there's no acceleration, then you're going to get applied force, which is forward. So we're going to assume that we've got this sign convention, that forward is positive and backward will be negative. It's just arbitrary. That means applied force minus frictional force also equals 0. So this is my F net equals ma. Applied minus friction is my F net. ma is 0, so then I can jump down here and say, well, look, if the applied force minus the friction is 0, that means the applied force is equal and opposite to the frictional force. So this statement here is because of that. I'm going to erase that because what a mess I've made. All right. Let me try that quickly again. This statement here is due to that situation. So I rearrange it using some algebra. So the coefficient of friction is equal to the applied force divided by the weight, which is the normal force, right? mg is the normal force. So normal force and mg are the same because it's on a horizontal surface. At least I'm assuming it is because I wasn't told there's an angle. So I'm going to assume it's horizontal. And then we've got our 450 newtons divided by our 9,810 newtons, which gives you a coefficient of friction of 0.0459. And I hope that helps out.